All right, hello everyone. All right, so this is week 7 material. So we're going to cover factoring polynomials. All right, so we're going to get started with factoring these trinomials, but let's kind of review what we did with multiplying polynomials, specifically what we did with multiplying two binomials. All right, so if you have x plus 2 times x plus 5, right? So we know that we have to multiply the first term, right? You get x squared. Then you have to multiply the inner term, which is, the outer term, which is the x and the positive 5. So you get plus 5x. Then you get to multiply the inner term, which is the positive 2 and the x here. So it's plus 2x. And then the last term, the positive 2 and positive 5, that's plus 10, right? Usually the middle term will combine, and you'll get x squared plus 7x plus 10. Okay, so that's what we've learned. Now, if you notice, we have a trinomial, and that trinomial stems from the product of two binomials. Okay, so basically, we can assume that every trinomial, majority of the time, will lead to the product of two binomials, right? So there is a method for that. There's not really a name for it. It's kind of the full method in reverse, right? But anyway, so let's go backwards. So how did you get backwards? Well, we know that the x squared here represent the first two terms of the binomials, right? X and x times x squared. Then the positive 10 here is the product of 2 and 5, the 2 and the 5. That's how I get the 10. Now, I also have to have the sum, right? Where did I get the 7x here? Well, if you look at the middle term, the 5x and 2x, it adds up to 7x, but it comes from the 2 and the 5, right? The 2 and the 5 is combined with an x variable, and therefore the sum of those last terms must be equal to the 7. Not only the last term of the binomial should be the product, it should match with the product of the last term, but it should also match with as a sum of the middle term, or the coefficient of the middle term. Okay, so let's try it out. All right, so my assumption is that, okay, this is going to turn out to be this, right? So the x squared is going to be what? X times x. Easy enough, right? Then now I go to the last term, which is the negative 27, right? And so you have a very few possibilities for 27, right? Because it's only what? 1 times 27, or 3 times 9. And that's it. That's the only options that you have, right? And one of them is going to be negative. So let's get to, but we know that 3 times 9 is 27, and 1 times 27 is 27. There is no other combination that's going to give you 27. So we're good. Now, the sum is going to have to be what? So the product is going to have to be negative 27, and the sum is going to have to be negative 6. And so 1 times 27, I could put a negative anywhere. It will give me negative 27, but 1 minus 27 is not going to give me negative 6. 27 minus 1 is not going to give me negative 6. So therefore, this cannot be, right? So what about 9 minus 3? That's positive 6, right? I don't have that. But negative 9 plus 3, or 3 minus 9, gives me negative 6. So we know that 3 times negative 9 is negative 27, and 3 minus 9 is negative 6. So that's my combination. So I'm going to put plus 3. And you could put the plus 3 here if you want. That doesn't matter. And then here, negative 9. That's it, right? That's about it. That's all you have to do for this type. Let's do another one. Let's do this one, and then we come back to number 2 here. Okay? Actually, there's another method for that, but I want to use. All right, so we have a trinomial. Let me use her. And we have y. Yeah, for the first term, y times y, right? And then now I'm going to go to the last one, which is positive 400, right? It's a big number, it's fine. And then I can have a multitude of option for 400, right? So I could have 1 times 400, right? I could have 2 times 200. I have 4 times 40 times 10, and then 20 times 20. I'm pretty sure there are some other ones, but let's stick with that, right? Now, since they're all positive, it's fine. Now, I want the sum also of those products to be equal to 40, right? So 1 plus 400 is not going to give me that sum of 40. 40 times 10, no. It's only the 20 plus 20 that's going to give me the 40. So 20 is my option here, right? 20 times 20 is 400, and then 20 plus 20 gives me 40y. So it matches. So I put it here, y plus 20, y plus 20. Okay? That's it. And the more you do those type of problem, you probably won't have to list, all the products. It will just come naturally. Okay. So now let's get back to number 2 here. All right. So this one you have to know a formula, which is the difference of 2 squares. Okay. All right, so the difference of 2 squared goes as follows. A squared minus b squared is equal to a plus b times a minus b. Meaning that when I factor a squared minus b squared, which is a polynomial, it renders, or it gives me a plus b times a minus b. That means the first term is the square root of the first term, a squared, and the b, the positive b or the negative b, is a square root of b squared. Okay? All right, so very important not to be confused with the sum. The difference means that we are subtracting. So there's a negative sign, not a plus. Always remember that a squared plus b squared is not factorable for, I need to specify here, real numbers. If I don't put that, then it's not accurate. But if I put it's not factorable for real numbers, then for us here, if you see something like m squared plus 4, right, you will not be able to put it as a plus b times a minus b. Okay, so this is not factorable. You will not have an answer. You see prime here, right? So this one will be prime. This one will be prime. Okay? All right, so with this here, let's apply this formula, right? So we want to apply this formula. So let's do this. So the first term, a squared, we need the square root of it, right? And that's going to fill these two spots. So we know that it's going to be the product of two binomial. So what is the square root of 25? Well, it's 5. So put 5 and 5 here based on what we see here. Now, what is the square root of m squared, right? What makes m squared? M times m. So we put m here, and you put m here. And then you can put the plus and the minus anywhere. Doesn't really matter. So put plus, minus. And that's it. That's all you have to do. A lot of you are looking at the screen and like, oh, it looks wrong. Well, you're thinking that maybe you should put m first and then the 5 next. No, that's not the same thing. So let's do another one here. M squared minus 25. M squared minus 25 would be m as the first term, and then 5 as a second term, and then you have plus 5, negative 5. Order is important here, right? So the first term here will be represented in the first term in the binomials, and the second term will be represented by the second term in the binomial. Okay, same thing applied here. Okay, so you got to be careful with these two types. All right. Okay, here's a new problem, number 4 here. All right, so this one is kind of, it looks a little bit different than the others, right? But no worries. So let's look at it. So what are we factoring here, right? Because it's odd looking. So if you really look at it, this is, so we have a binomial here, which is a plus 13 and a plus 13, right? So you have two terms, and we need to recognize that we have two terms here. Like for example, this whole thing here, this product is one term, and this is another term, right? And what we want to do, right? A term is when you have the product of two items, and we do have that because here we have 12 times something, so that's a term. Okay, so y times a plus 13, that's a whole term. Okay, even though within the parentheses you have an a plus 13, but what makes it a term is the 12 times that binomial. Okay, so usually terms are separated by sign, or like the addition sign, the subtraction sign, and the equal sign. Okay, so plus minus. So like I said, because a plus 13 is inside the parentheses, you look at it as 1, right? And the 12 times a plus 13 makes it one term. So anyway, because now we want to factor this, we are looking for something in common, right? Which is called the greatest common factor. And the only thing that is in common for those two terms is a plus 13, right? So the only thing that is in common here is the a plus 13. And so this is what we're going to factor out. So if you factor it out, right? So you can look, let's say I'm replacing, let's say B. Let's say I use the letter B to represent a plus 13. So if I were to do that, I will have 12b minus yb, right? And if they tell you to factor this, then you know that b is the greatest common factor. You will put b on the outside, then put parentheses, and whatever is remaining, when you factor out the b, then you will put 12 minus y, right? You have the 12 and the minus y, because you extracted out the b from the two terms. That's called factoring, right? So now that I know that b is equal to a plus 13, now I can replace b with a plus 13 times 12 minus 1. That's it. That's the way you deal with this one. Okay? So obviously, you don't have to replace by b, but if it helps you in your process, then please do so. All right. So let's kind of move on. All right, so I'm not even going to do number 5 here because we recognize that we have what? The two squares, right? We have x squared and 36 here, right? But do we have a difference or a sum? We have a sum, right? Because you have a plus. So here we cannot put this as a plus b times a minus b, right? It's impossible because I just talked about that. So that's a no-no. Okay? So what do we know about that? What did I say about this? I'd say that these are not factorable. Well, this sum of two squares is not factorable, therefore it's prime. Okay? All right, so we already did something like this in the first two problems. So I'm going to skip that. And I want to get to probably something like this. Okay. All right, so let's do this. All right, so here we have a polynomial, right? But it doesn't look like a quadratic in a quadratic form, right? So it seems like we have to do some additional stuff. It seems like we have to look for the greatest common factor first, and then maybe do some additional factor. So let's look at the greatest common factor. It seems like 6 goes into all those values here, right? It is a factor of 126 because 6 times 21 is 126. 6 times 10 is 60, and 6 times 1 is 6. That's one of my greatest common factors. For the x variable, we want to make sure that we factor it out, right? So it seems x to the power of 1, or just x, is my greatest common factor, right? If you are yeah, so x is the greatest common factor. Okay. So now inside the parentheses, I should have 3 terms remaining, right? And so what are the remaining factor? Well, 6x times what gives me 6x cubed? It's going to be x squared, right? Minus a factor of the 6 and a factor of 1x. So I should get 10x, right? And then we know that 6 times 21 is 126, so I should have 21 left, positive 21 left. And then the x here, we extracted out, so it's right here now. So it's just positive 1, but I'm not going to put the positive 1. So we are done with this first part. So I factored out the 6x. Now I have a nice trinomial that I can factor also, like the way we did it for the first two problems. So let's go to, let's do that. So 6x is still a factor, so I have to write it out, 6x. And then this trinomial, I'm going to factor that as the product of two binomials, hopefully. And then I have, for x squared, I should get x times x, right? Possible factors of 21, where the sum is equal to negative 10. So for 21, there's only 1 in 21 and 7 in 3, right? So 7 and 3 must be it. But that 7 and 3 has to give me a positive 1 when I multiply them, and a negative 10 when I add them up, right? So it seems like negative 7 and negative 3 are the candidate for that, right? Negative 7 times negative 3 is positive 21, and negative 7 plus negative 3 is negative 10. So therefore, this is what we have. Okay? That's it. That's your answer. All right, so moving on. All right, so this is a good one to do. So this one, you are given a polynomial, but with 4 terms, right? So automatically, if you see a polynomial at this stage, if you see a polynomial with 4 terms, you're gonna factor by grouping, right? So you're gonna factor by grouping. Okay. All right. So what do we mean by that? Well, Factoring by grouping means that you're going to group the first two terms, and you're also going to group the last two terms. And within those grouping, you're going to factor out the greatest common factor. And then whatever is left inside the parentheses must be identical. The goal is to have those two being identical. So let me show you. So what is the greatest common factor between 5a squared and 5ab? It seems like that 5a is your greatest common factor. So 5 is common, and then here there's only one a here. There's two a's here when you multiply. So we factor out just one of them. That's 5a. So we are left inside the parentheses with a. 5a times a is 5a squared. Plus, we remove the 5a from the second term, so we're only left with b, right? And then here, I'm expecting, when I factor the greatest common factor here, to have a plus b, okay? So whatever you have in the first grouping here, when you factor out your greatest common factor, you must have the same thing when you factor out whatever is in the greatest common factor is, okay? So here, in order for me to get a plus b, if I factor out just the 7, I'm going to get negative a minus b. That's not what I want. So therefore, I'm going to factor out the negative 7, and then I'm going to have a plus b, right? So here, if I factor out the negative 7, I'm going to have a plus b, okay? All right, so we discussed this before, right, in one of the examples before. So we know 5a times a plus b is one term, and 7 times a plus b is another term. So therefore, I can factor out the a plus b, or you can say c is equal to a plus b, right? And you replace a plus b with c. So it's going to be 5a times c minus 7c, right? What is the greatest common factor between those two? Is actually c. So you factor out c times 5a minus 7. But you're not done, because you have to replace c with a plus b. So you're going to have a plus b times 5a minus 7. And that's it. That's your answer. Okay. And that's that. Okay, so we didn't do one with multiple variables, so let's do one with multiple variables, and then we'll do those type here, number 12. Okay, so let's do this one here, right? So you have a trinomial, so we're trying to factor this. All right, so x squared, we know it's x and x, okay? But now we have an additional variable, right? So we shouldn't worry about it, because the last term involved y squared. So we know we're going to have a y here and a y here. So that solved that problem. So now we don't have to take care of the, we can dismiss the y, because we know it's going to be y times y being y squared. So now all we have to do is take care of the 5 and the negative 14. So we know we need the factors of negative 14 where the sum is equal to positive 5. So it can only be 7 and 2. But 7 has to be positive, and 2 must be negative, because 7 times negative 2 is negative 14, right? And then 7 minus 2 is equal to positive 5. So put positive 7y, and then negative 2y. Okay? And that's it. All right, let's move on. All right, so let me see if I wanted to. No, right, so that's the one we're going to do. Maybe I should choose. Let me see. Probably try. Just give me a. All right, so for this problem, we're gonna we're gonna use a method called the AC method, right? AC method stems from the format of this trinomial, which is ax squared plus bx plus c, right? And what we're going to do, we're going to be using the coefficient of the first term, which is a, and the coefficient of the last term, which is c. Okay? All right, so it goes as follows. So the goal is to, just like we did before, factor in this fashion. Okay? So our goal is to factor and get, but you can see that our problem here, to factor this, we need another approach that we cannot use the approach that we have for the previous one, because now we have a value in front of the x squared. Okay, so our approach has to be a little bit different. So let's talk about the AC method. All you have to do is to first multiply a times b. So you have to find a times c. And in this case, a times c is 8. A times 3, sorry, a times 3 is 24. Okay? Okay. So with 24, you have to find, so our goal is to find factors of 24. So factors of 24 where the sum is going to be negative 10. Okay? Wow. Okay. So let's find them, right? So what are the factors of 24? We have 2 and 12, right? But it has to be 2 and negative 12, correct? All right, so we have that. We also have 6 and 4, right? So let's try 6 and 4. 6 and 4. And both of them has to be negative. Negative 6, negative 4. Okay? What else do we have? We have 8 and 3. But 8 and 3 will not give you a sum of negative 10. Correct? So 8 and 3 is not going to work out. Okay? And 1 and 24, we know, right? So we can just put it, just for the sake of putting it, right? Factors of 24, where the sum is going to give me negative 10, right? So maybe I should put where the sum is negative 10, right? The negative 10 comes from the middle term. Okay? So we have those two here. So let's take, I mean, it seems like we can use any of those two. Let's see. Let's try this one first. Okay. So once you have identified the factors of 24 where the sum is equal to negative 10, right? So you take one of them. So we're going to take 2 and negative 12. And then what we have to do here is to rewrite this as 2x minus 12x. That's what we're going to do. Okay. So we're going to put an x next to them. And now, because we know that 2x minus 12x is equal to negative 10x, we're going to replace. So what we're going to do here is replace negative 10x with 2x minus 12x. So let's do that. So next step will be 8x squared, right? Oops. Plus 2x squared minus 12x squared. Minus 12x, I'm sorry. And then plus 3. Okay? All right, so I already see a problem there. But let's go through the process, right? Because, you know, whatever we're getting, you know, if it, because everything has to work out. So what do we, so the 12x here, right? So I'm going to put in green. The positive 2x squared minus 12x is replacing this. Okay, so now we are compliant, right? Everything should match. Everything is fine here. Now, let's move on now. So now you can see that we have what? 4 terms, right? We have 4 terms. So what do we have to do? We have to factor by grouping, and that's exactly what we're going to do here. So I'm gonna rewrite this here: 8x squared. Oops, use the same color here. 8x squared plus 2x squared minus 12x plus 3. Right? So I'm grouping this, I'm grouping this, I'm grouping this. Right? What is the? I'm sorry. I put the 2x squared here, which is wrong. Sorry. Okay. Now it's correct. Now, what is the greatest common factor? It seems like 2x is the greatest common factor, a factor of the 2x, right? And then it gets inside the parentheses 4x plus 1, right? However, we have a problem here with the negative 12x, right? We do have a problem with the negative 12x and the 3, because even if I factor out just the 3, right? So let's factor out the 3 plus 3, then I have what? Negative 4x plus 1. Negative 4x plus 1 is not the same as 4x plus 1. So that's a problem. If I factor out the negative 3 out of the 2 terms, it gives me a 4x minus 1. It's still not 4x minus 1 and 4x plus 1 are not the same. So it seems like this never going to work out, right? So if I didn't make any mistake in my factoring, right, 2 plus minus 12x is indeed negative 10x, right? This combination is not working, right? So you have to. So you're gonna have to go through that process. Usually it doesn't happen like that. Usually you get 1 and then, but in this case we got 2 sets of factors that is equal to the negative 10x. Okay, usually that's unusual, but it may happen. So I'm glad that it happened there. So this not gonna work with this. Okay, so it has to be negative 6 and negative 4. So let's try it out. So let me kind of erase the stuff there. All right. Now we're going to try with negative 6 and negative 4, right? So the negative 6, so here, we're going to negative 6x minus 4x should replace, right, negative 10x. Okay, so let's do it. So we have 8x squared minus 6x minus 4x plus 3. Okay, so I think I'm the one who wrote my problem wrong. I must have. Yeah, yeah, I think I believe I wrote it wrong, or actually it's not going to work out. with any of those two. So this one might be a prime. Okay. So this is a prime example. This is not the type of problem that I wanted to have. But anyway, it's a prime. So it's okay. So we go through the process and then we're going to do another one. Okay? The next one. Because I just randomly took one. So anyway, so let's go through it. But don't worry. All your problems not going to be like that where you have to go through this whole process. But at least you get the practice or the exposure. All right, so you factor out the greatest common factor. In this case, it would be 2x. And you get 4x. So you pretty much get the same thing. 4x minus 3. Okay? And then you factor out, well, here, actually, if you factor out the negative 1 here, so it's going to work out. It's going to work out. It seems like. Yeah, it's going to work. So here, 4x minus 3 is not the same as negative 4x plus 3. So I rushed into a conclusion here. All right, so all you have to do here is to factor out negative 1, right? And then you get 4x minus 3. Beautiful. So I'm sorry, at first glance I thought it was not going to work out, but it is working out, okay? So you have the ax squared minus 6x minus 4x plus 3. It's working out. All right, so going through the process, you can see that we have 4x minus 3, and we have 4x minus 3. And now we can factor out the 4x minus 3. So I'm just going to put 4x minus 3. And then here, the remaining, which is a 2x, and the minus 1. So 2x minus 1. Okay? And that's it. Okay? So you saw when we had the 2 and negative 12, when we plugged it in, it didn't work out at all. Right? I'm wondering if I had to factor, yeah, we tried to factor whichever way, and it didn't work out. So I think we are good. Negative 6 and negative 4 is perfect. Okay, let's do another one. And, all right, so here's the other one. So AC method, you can see the 6 represent the A, and the negative 5 represent the C, right? So it's going to be negative 30, right? So find factors of negative 30, right, when the sum is positive 1. So I can only see negative 6. Oh, no. I'm sorry. Positive 6 and negative 1. Oh, I'm sorry. Positive 6 and negative 5. Right? Because 6x minus 5x is equal to, it's not x by the way, it is t. So 6t minus 5t is equal to positive 1t. Right? So that's my combination here, right, that I want. Okay? There's no, so you have a 3 times 10, right? You have 1 times 30. These two combinations will never get you to positive 1t, right? So this gives me positive 1t. I'm good. I can replace 1t with 6t minus 5t. But this is what I'm going to do. So 6t squared minus 6t minus 5t minus 5. Right? You have 4 terms. Use grouping. And then here the 6t is to be factored out. That's a t here. So 6t. It's being factored out. So you have t minus 1. Oh, I'm sorry. It's positive 6t. Right? So I'll put a minus there. It's supposed to be positive 6t. That's what we have here. Okay? And then here, if I factor out the negative 5, then I'm going to get t plus 1, right? So factor out the negative 5, and then I get t plus 1. Okay? Now I can factor out so I can see the t plus 1 is my common factor. So factor out t plus 1. And then whatever is left, which is the 6t and the negative 5, put it inside the other parentheses. And you are done. Okay. All right. So that's that for factoring, right? So this is kind of the same thing. You have 4 terms. You factor. Well, maybe I'm going to do this one. This one is an interesting one. And then we get to equations. All right. So this one, we have 2 terms, right? And they are definitely, and then we have a minus here. But here we do not have the difference of 2 squares, right? That's because that's what we've learned. But what we can do is first find the greatest common factor, which is just x in this case. So let's do that. So let's factor out the x. Then we get 16 minus x to the power 4. Okay. Now, do we have the difference of 2 squares? Well, even though my polynomial here doesn't look like a squared minus b squared, right? It doesn't look like this, but that's not the only one that's gonna, factor as a plus b times a minus b. If I have a to the power 4, minus b to the power 4, I can write it as a to the power 2 plus b to the power 2 times a to the power 2 minus b to the power 2. That works out. Okay? Same thing for a to the power 6 minus b to the power 6. Okay? It's going to work out too. Put a to the power 3 plus b to the power 3 times a to the power 3 minus b to the power 3. Okay? As long as the exponents are even, you can write it out like this. All right, so it seems like it works out. It is a difference of 2 perfect square. That should be the name of it. Okay, so if I can do that, but now the question is 16 a perfect 4th root? Yes, it is. Because 16 is also a perfect square, meaning that 2 values that I'm going to multiply, two same value that I'm going to multiply, that's going to be equal to 16. So 4 square, right? So 4 times 4. But also, you can write 16 as a product of 2 times 2 times 2 times 2, which makes it a perfect 4th power, right? And so it fits. So I can rewrite this as x times actually I gotta, yeah. So I'm sorry, let me rephrase because I'm going way ahead. So yeah, so here 4 times 4 and x squared times x squared. So that's why I want, 4 times 4, because I'm confusing. 4 times 4 is 16, and then here x squared times x squared. Okay, so beautiful. That's why we know it's a perfect square. So I can write this as 4 plus x squared, and then 4 minus x squared. Okay. All right, are we done? That's the question. Well, here we have the sum of 2 squared, right? So we know this is not factorable. But here we have 4 minus x squared, which is the difference of 2 squares again. So we need to continue on and factor this. So these two here is going to remain x times 4 plus x squared. And then here we have, right? So now it's going to be 2 times 2. And then x times x, right? So we know it's going to be 2 plus x times 2 minus x. Okay? And that's it. That's your answer. Oops. So sorry. Here we go. All right. So this one, kind of rewind and, go through the process again if you have to, because you may see something like this. All right. So let's move on to solving equation of polynomial equation. All right. Now, we have two binomials. So we have what we call the zero product rule in algebra, right? So the zero product rule tells you that if a times b equal to 0, then either a equal to 0 or b equal to 0. That's the zero product rule. Okay? All right, so a times b, you can view them as factors, right? And that's what we have. Let's say, imagine that a is x minus 2 and b is x plus 4. And it is equal to 0. That's a condition. So therefore, I can separate those two, a and b. I can say x minus 2 now is equal to 0, or x plus 4 is equal to 0. And now I can solve for x minus 2 because it's a linear equation, right? So we know how to do that. So therefore, x is equal to positive 2, or x equal to positive, not positive, negative 4. Okay? And that's it. That's all we have to do. So that's going to help us a little bit later in solving some more complex polynomials. All right, so let's move on. All right. So that's going to help us solve this one. All right. So to solve a polynomial equation by factoring, you always have to have your standard form in the following manner. It has to be ax squared plus bx plus c equal to 0. Right? Your polynomial should always be equal to 0 in order to solve. Otherwise, it's not going to work out. Okay? So, is it in this format? No, this one is not in this format, so we need to rearrange it, and we should have x squared plus 3x. And then the 40 is going to move to the left side now and becomes negative 40. So put negative 40 now right next to the positive 3x and make it equal to 0. Now. Okay, so now we are in business. We can go to the next step and do the factoring now, right? Because now we know how to factor the x squared plus 3x minus 40. Let's put it in factor form. So here, we assume that's going to be the product of two binomials. And we're going to get x and x. And let's look at product of 40 where the sum is positive 3. What could it be? 8 times 5 is 40, right? But I want the sum to be equal to positive 3. So it has to be 8 and negative 5, because 8 minus 5 is positive 3, and 8 times negative 5 is negative 40. So that's perfect. So put positive 8, negative 5. Okay? Now, we follow the product rule, the zero product rule, and we set x plus 8 equal to 0, or x minus 5 equal to 0, which means that x is equal to negative 8, or x equal to positive 5. So negative 8, positive 5 are my answers. Here we go. All right, so you may get some like this, right? So don't get scared. So again, polynomials should be equal to 0. So you say x times x minus 6 minus 40 equal to 0. But, so you look at this, you're like, oh, this looks strange. Because, I can't figure it out. It doesn't look like a trinomial. What do I do? Well, what you can do is basically expand this, right, by using distributive property. And so you get to x squared minus 6x minus 40 equal to 0. And then you go into your factoring mode, and in this one's going to be x and x. And then I'm going to use a 4 and 10, right? Because 4 times 10 is going to be give me the 40, but I need a sum to be equal to negative 6. So it has to be negative 10 and positive 4, right? To give me negative 40, but also the sum being equal to negative 6. So let's put plus 4 and negative 10, and that should satisfy this polynomial. And now we can set x plus 4 to 0 and x minus 10 to 0. So we have x is equal to negative 4 or x equal to 10. So 84, 10 are my answers. All right. So this you can do on your own, right? So it's basic. All right. So that's it. All right. So I covered pretty much all the factoring methods and type of problems. So that is it. If you have some additional questions, please send me an email.